Hi everyone, I'm Fengming. Today I'm going to present our work, Ubi Edge, authoring edge-based opportunistic tangible user interfaces in augmented reality. This work was completed with my collaborators, Xiyun, Jingyu, Xuyun, Tianyi, and my advisor, Dr. Karthik Ramani from Convergence Design Lab at Purdue University. Let's get started. Tangible user interfaces allow a user to interact with digital information through the physical environment. With the advent of mixed reality, TUI has become one essential way for rendering haptic feedback in AR. Further, Opportunistic TUI tightly maps the affordance of physical objects with the functions of virtual widgets like buttons, sliders, and lobes. The time mapping of Opportunistic TUI provides a more intuitive connection between the user inputs and the digital services. However, such stream mappings usually require users to find an object with similar shape and size as the AR content, which limits the generalizability of TUI. And this inspires of leveraging local geometry features instead of the entire object to customize Opportunistic TUI. Specifically, we focus on geometry edges and sides, which are ubiquitous on everyday objects. Edges can also provide sharp tactile feedback, and users do not need to pay full attention when interacting with edges. For example, we know where the edge of a desk is through direct touches, and we do not need to look at it. Then how to let users utilize edges to author an opportunistic TUI application. We divide the input edges and the digital output into different categories, and the different combination of input and output can result in various TUI applications. Specifically, we categorize the touch input into binary touch and consecutive sliding, so that the system will treat the edges as buttons and sliders, respectively. We also divide the output into discrete and continuous. For example, in the subfig B with a combination of consecutive input and continuous output, the cube's movement will be linearly mapped to the user's sliding input. After understanding our system basic taxonomy, an important problem now is how to track the geometry edge of an object. In Ubi Edge, we design a vision-based processing workflow so that our system can accurately detect the edges on everyday objects. Rather than extracting wall edge lines on the object, the edge detection here is to extract feature points on the object. Then we let users define their own tangible edge inputs by sliding their fingertips on the overlaid feature points. In detail, we first use a real-time RGBD edge detection algorithm to get geometry edge points. We also use a network-based key point descriptor to track the 6th degree of freedom of the object. Here are some edge point detection results using our tracking workflow. Now we use an example to demonstrate the workflow of Ubi Edge. One day, a user wants to author a SmartNet controller TUI by interacting with the frequently used cup. For example, the user wants to turn on or off the SmartNet by touching the handle of the cup. The user first enters scan mode of Ubi Edge and looks at the target cup for a few moments. Then our system captures the RGBD information of the object to extract geometry edge points on the object. Next, the user enters auth mode to define the edge of interest by simply using the index finger to slide along the handle. Now, the user sets the edge input type as binary so that our system treats the input as a button. Then the user selects an on-off digital function of the net and connects the synaptic edge input with the digital function through visual programming. If the user wants to set a continuous output, the user needs to specify the range of the output function. Here, the user sets a coupling to adjust the color of the SmartNet. Now, the user can turn on or off the net bulb using the handle of the cup. Or the user can adjust the net color by sliding left and right along the rim of the cup. As the edge properties affect the edge detection results, we evaluated the effectiveness of edge detection with different parameters, including edge length, sharpness, and the distance between edges and the camera. Here, we use the different rounded edge radius and angles between two surfaces to represent the impact of sharpness. Overall, our results show state-of-the-art performance compared with previous works. Here, we showcase 4 TUI applications created by our system. With Ubi Edge, a user can turn physical objects into a multifunctional controller. The user uses a book to turn on or off the air fan, let the fan oscillate, and change the fan's speed. Users can also use edges on physical objects to control IoT items. The user here uses a skill to let the audio player start to play, jump to next song, and change the volume. With our system, users are able to create tangible AR games that use everyday objects as controllers. Here, a user uses a game console switch to interact with a basketball shooting game. Ubi Edge can also improve users' task efficiency by enabling users to control tutorial-based TUIs. We conducted a 2-session user study to evaluate the accuracy of the touch interaction with edges, TUI authoring feasibility, and overall system usability. We provided 6 daily objects, and they vary in size, edge numbers, and edge curvatures. The first session is a quantitative evaluation of the touch interaction, and the second session is a qualitative evaluation. In the first session, for each object, users can choose any 2 tangible edges they want. One authored edge was set to binary, and the other edge was set to consecutive. We ask the users to perform 5 touches for each binary edge and slide along the consecutive edge to reach specific points on the edge. For binary edges, we counted whether the edge detected touches, and for consecutive edges, we recorded the completed time. Overall, our system could accurately detect the touches and accurately manipulate the authored tangible edges. In the second session, we evaluated the performance of Ubi Edge authoring interface. We asked users to finish 6 TUI authoring tasks, which include all 4 combinations of inputs and outputs we mentioned earlier in the taxonomy. In general, users show a high preference for using geometry edges as tangible inputs, and they agree that repurposing tangible edges into controllers is intuitive. Thank you for watching. For more details, please refer to our paper and video.